Good morning, children. Welcome to your chemistry online class. We have successfully completed last chapter. So from today onwards, we are starting new chapter called States of Matter. Let's begin.
From your childhood, from your previous classes, you are learning that matter exists in three forms. Those are solid, liquid, and gas. And we know the properties of such substances. And even though there is one more state of matter called plasma. And if we check the properties, we know from this image it is clear that solid is rigid, liquid is not rigid, gas is not rigid. And we will get to know the idea that solids having fixed shape. Liquids doesn't have a fixed shape, but in which container or which vessel it will take or it will adapt that shape. And gases are having fixed shape. And solid having fixed volume, liquids having fixed volume, but gases doesn't have a fixed volume. These are the properties of matter. I hope you all know these things. And we know these all substances are existing. So there should be some force. Such type of forces are known as the forces between the constituents in a matter is called intermolecular forces. So how can we define the intermolecular force? Intermolecular force is the attractive and repulsive forces. It is abbreviated as IMF. So these are arise between the molecule of a substance. These forces mediate the interaction between individual molecules of a substance. So most of the physical and chemical reactions are held due to these intermolecular forces. So the forces exist between the molecules themselves and those are collectively called as intermolecular forces. So there are different types of intermolecular forces. So we'll see what are the types of intermolecular forces. Maybe it may be attractive forces or repulsive forces. For example, if there is an positive and negative ion in a substance, then there is an attractive force. But if it is two particles are positive, then repulsive. Similar, if the two particles are negative, again repulsive. So there is attractive force also there and repulsive force also there. So we are going to deal with the attractive forces. If you see this image, you can see that two HCl molecule, intermolecular forces. So we know in a molecule or in a compound there are many atoms or many ions or many molecules. If you take a compound, we cannot count or we cannot tell this much amount of substance are there because we cannot see it by naked eyes. The molecules, atoms are very small. So there are a lot of, we know the Avogadro number 6.023 into 10 raised to 23. So these much atoms of a molecule or atoms are present in 1 mole. So can you imagine how much compound or how many atoms are exist in a compound? So in between these molecules there will be some forces, some attractive forces. So here you can see this interatomic forces, intermolecular forces, etc. So these intermolecular forces are depend upon the following interactions. We can see there are several types of interactions. The first type is dipole-dipole interaction. So what do you mean by dipole-dipole interaction? What do you mean by dipole? We have studied this dipole. Dipole means charge. So this type of attraction is exist in polar molecule. Polar molecules have permanent dipole that are formed due to the difference in the electronegativity. For example, we can see here, we know HCl. HCl is a covalent compound. So hydrogen and chlorine are there. So if you take hydrogen and chlorine, we know chlorine is more electronegative compared to hydrogen. So in this case, what will happen is the chlorine have the ability to attract the shared pair electron towards itself. So what will happen? There will be a charge induced or charge created in the atom, in the molecule. So we know in a compound there will be so many HCl molecules. So in between them, if you take them, the chlorine ion of one molecule and the hydrogen of other one will attract towards itself, because one is negative, another is positive, so they will attract each other. Such type of attraction in the polar molecules are called dipole-dipole interaction. The one HCl molecule is a one dipole and another HCl molecule is another dipole. So such interactions are known as dipole-dipole interactions. The next one is iron dipole interaction. What will be iron dipole interaction? It is due to, there we have seen two polar molecule or two molecule. Here the interaction will be between one iron and a polar molecule. The iron may be anion or cation. See here you can see in the image, if NaCl mixed into water, what will happen? They will dissociate into Na and Cl. So Na plus iron and the water. So Na plus is an anion and water is a polar molecule. So there will be an interaction between this Na plus and water. Similarly, there will be an interaction between chloride and water. Such interactions are known as iron dipole interaction. So one dipole will be there, that is a polar molecule, H2O, HCl, these are polar molecule, and one iron will be there. So iron and dipole interaction. And the strength of this interaction depends upon three factors. Those are the magnitude of the dipole moment, size of the polar molecule, the size and charge of the ion. These are the important factors of iron dipole interaction. And the third type, that is ion induced dipole interaction. What do you mean by induced? It is very easy. This is also similar. That is, this interaction will be between a iron and non-polar molecule. From this time we have seen the polar molecule, but here there will be a non-polar molecule. For example, O2. O2, because two oxygen atoms having same electronegativity. So they have the same symmetry. There won't be any charge. So it is a non-polar molecule. So what will happen? If an ion come closer to the non-polar molecule, due to the charge of this ion, there will be some induced force, because we know oxygen having high electronegativity compared to iron. So there will be an attraction induced between this molecule due to the iron. Such interactions are known as iron induced dipole interactions. So then what will be dipole induced interaction? Very similar. A polar molecule induce a charge on the non-polar molecule. Because if we take H2O and O2, H2O is a H2O and Cl, such any other type we can take. So H2O is polar and Cl2 is non-polar. So what will happen is, there will be a attractive force will begin between the polar and non-polar molecule. Because the polar molecule come nearby the another molecule, there will be a charge created. So such interactions are known as dipole induced dipole interactions. The next one is dispersion forces or London forces. It is a very short distance and it is the weakest one in these interactions. This arises due to the movement of electrons, thus create a temporary positive and negative charges in certain regions. Such interactions are known as dispersion forces or London forces. So I hope all of you understood the type of interactions. So we'll start or we'll see another topics in next class. Thank you.